We're going to get into rational functions shortly. However, just going around, I've seen lots of people independently struggling with a particular part of this question. So I figure it's worth addressing now. Okay. You can see I've got my y is less than or equal to x squared minus 4, so there's my parabola. And y is less than the absolute value of x, so there's my bouncy line. And there's my green region. Okay. But the last thing that's left, it's the last thing most people solve, is these points of intersection. Okay. Now, unfortunately, because of the numbers, it does turn out to involve some irrational numbers. Okay, so we're going to have to work this out. We can't just look at it. Okay, but there's a point of confusion because of this absolute value, right? Because if you solve it, right? If, for instance, you go absolute value of x, right? What's that equal to? That's x and minus x, right? So you think, okay, I've got to solve this equation. That'll give me some points of intersection. And then you solve this equation, okay? And when you solve both of these, you'll get two solutions, 4 solutions. Which ones are they, okay? And that's what people are confused about, okay? So I think what we'll do is, if we take a step back, this question is not as hard as it looks. Partly as well because of the symmetry we've got here. Both of these functions are even functions, so their points of intersection will just be, you know, a and minus a, okay, just flipped around. So we shouldn't have that much work to actually find the values of these, right? But just assuming we didn't know about even symmetry, okay, how would we solve this anyway? Or, you know, if they weren't even, what would you do? Okay. Let's start with actually labeling the branches of the graph as they're different, right? So this part over here, the one that's going up, okay, this is got a gradient that's increasing, so that's y equals x, and the other one is negative x, okay? Now, I like positive numbers because they're easier to deal with, so I'm just going to think about this part over here, okay? But the important thing to get about this line, y equals x, right, is it doesn't go through the entire graph. It doesn't go on forever, right? It's got all these positive values, but then it stops at x equals 0, right? So a way of saying that is y is equal to x when x is greater than 0, and only when x is greater than 0, and that will be important in a second, okay? So when you go ahead to solve this, you want to find the points of intersection, so you solve simultaneously. You go x is equal to x squared minus 4. You rearrange to have everything on one side. Sorry. You stare at it for a little while to try and factorize it, and then realize you can't, so you go to the quadratic formula, right? This is what you do, right? That's what I do. Okay. So I think in the end you get something like what? 1 plus the square root of 17. Yeah. I think, yeah. On 2. That's 2a. Okay. Sorry, plus or minus, yeah? So here's my 2 solutions, right? But I know I don't want both of them, because when I actually look at my graph, this part here and this part here only intersect once. So I'm going to have to exclude one. The question is which one? Depends on this, okay? So these two values, 1 minus the square root of 17 on 2, and 1 plus the square root of 17 on 2, okay? If I only want the positive one must be positive and one must be negative, okay? Now you don't need a calculator to work out which one's which, okay? Because which one is bigger? This is a plus and this is a minus, so this must be bigger. Another way of thinking about it is the square root of 17. I don't know what it is, but it's got to be close to the square root of 16, which is 4, okay? So you got like 1 minus 4, that's negative, okay? So I would say, but x is greater than 0, okay? This is why it's important to note down your domain before you start anything. Therefore, x is equal to just this one. Okay? Now, there's my coordinates. Here, 1 plus the square root of 17 on 2. And I guess you'd sub that in. No, you don't need to sub it in because the y and x values will be the same. So 1 plus the square root of 17 on 2. Okay? There's one intersection point. In this example, like I said before, it's even, so you can just read off the graph and say, by even symmetry. Right? This will be minus 1 minus the square root of 17 on 2. But the y value is the same, right? Because over the same, it's positive, right? When they're not even, you can't just do that. What are you going to be forced to do? Redo this, but for the other side. So you're going to say, well, on that side I've got minus x. For when x is negative, right? And then you keep on going, you'll get to this point, okay? And you'll say x is equal to, let's see here. I'm going to have minus 1 minus root 17 on 2, or minus 1 plus root 17 on 2. Okay? And exactly the same way, or reversed, I guess, you say, I only want the negative one. And this is not negative, right? So you exclude it just like you did before, and you get one solution, namely that one. Okay? So that's how you know which roots you're interested in.